Okay, the standard deviation, once we calculate that using our calculator, it is very useful in comparing different data values from different data sets. So if they have different means and standard deviations, then comparing them can be misleading. So for example, different scores on different tests. So what we want to do is calculate how far each data value, what we calculate is how many standard deviations away from the mean it is. And this distance then is divided by the standard deviation to find out how many standard deviations are in the distance. So here's the formulas for this. They're actually called z-values, and we're going to use these a lot when we get into chapter 6. But our formulas for a sample to calculate to this, it's really called a standard normal variable. We'll talk about that later in chapter 6. But really what it's doing is calculating how far away a certain data value is from the mean, so it subtracts it and divides by the standard deviation to calculate how many standard deviation is. And then for a population, it's just x minus mu over sigma because mu is the population mean, sigma is the population standard deviation. Whereas in our sample, x bar is the sample mean and s is the standard deviation. So it might make sense if we kind of look at a example here. So we have two students, John and Allie, from different high schools, and they wanted to find out who had the highest GPA when compared to his high school. So if we look at John, his GPA is 2.85. His school mean was 3.0 and standard deviation of 0.7. Whereas Allie's had a totally different scale. So her GPA was 77 with a mean of 80 and a standard deviation of 10. So we want to calculate their z-scores to compare which one really had the higher standard deviation. So we're going to use this formula here. Z equals x minus mu over sigma. So let's calculate it for John. So Z for John, we just wrote a subscript of John here. His GPA is 2.85 minus the school mean. So we do the 2.85 minus the mean of 3.0 and divide it by the standard deviation of 0.7. Okay, so let's look at our calculator here. Okay, so I'm going to use parentheses so I can do it all in one step. 2.85 minus 3.0. If you don't use parentheses, it won't subtract at first. It'll only divide the 3.0. So divided by 0.7, enter. And I'm just going to round it to 2 decimal places. So in your homework, just watch what it tells you. So we have negative 0.21. Okay, now let's do Allie's. Back over here. Allie's GPA is 77 minus the mean of 80 divided by the standard deviation of 10. Let's go ahead and do that. I'm going to do parentheses 77 minus 80 divided by 10. So negative 0.30. Okay, so the question now is, what is this telling us? So basically, if our distribution is symmetrical, I'm just going to assume it is here, okay? Here, basically my mean, if I look at how many standard deviations away from the mean is the mean, it's going to be 0, right? So 1 standard deviation would be to the right, 2 standard deviations, 3 standard deviations. If we go to the left, -1 standard deviation, -2, -3, we'll talk about this later. But when we look at these two numbers, John's -0.21 is about right here, right? So he's just a little bit below the mean. Whereas Allie's is negative 0.3. So she's actually to the left a little further, right? So she's a little further below the mean. So John's is actually a little bit higher than Allie's. Make sense? So basically what our Z values tell us is it tells us if the mean is right here at the center, how far or how many standard deviations away from the mean their score is. So John's score was negative, and that just tells us the direction to the left of the mean, negative 0.2. Allie's was also below the mean to the left of the mean of 0.3. And you can see that makes sense because in John's, his GPA was below his school means, and Allie's GPA was also below her school mean. Make sense? Now, when we think about this in terms of, I'm going to just scroll back up at the end of the last video. I didn't talk too much about the empirical rule and Chebyshev's theorem. The difference here is the empirical rule applies to bell-shaped data. So Chebyshev's would be any shaped data. So if I just draw you a little picture here of what this empirical rule is telling us, it's telling us, again, if our mean's at the center, if we did a histogram and a shape of our data is bell-shaped or symmetrical like this. Basically, again, if I think of my 1, 2, 3 standard deviations above the mean, 1, 2, 3 standard deviations below the mean, what the empirical rule is telling me is that 68% of the data fall within 2 standard deviations of the mean. Actually, that's not correct. It should be 1 standard deviation of the mean. I apologize. And this one should be 2, and this one should be 3. My fault there. Can you correct that on your sheet? I'll go in and correct it if I can. So 68% of your data fall within 1 standard deviation of the mean. That's what the empirical rule tells us. And then it tells us 95% fall within 2 standard deviations of the mean. So that means 95% of our data fall within between these two, whatever these two values are. And then it also tells us that 99.7 fall within 3. Make sense?